Thanks to virtualization, we can increase data rendering efficiency. This means that if we have a table or any list with a lot of data, for example, let's say 5,000 records, displaying them all at once in a for each loop is a heavy load. So, as we are doing now in our tasks view, we display this table in a for each loop. In such cases, if there are a lot of records, it's worth using virtualization, which renders only the elements currently visible on the user interface. Therefore, virtualization is useful in situations where we have a lot of data, but only a fragment is visible to the user at any given moment. So now, we will change this for each loop to display the table using virtualization. The change is very simple. Just add a new virtualized component and it will replace the for each loop. So, I'll comment out the for each loop so you can see how it looked before. Now we'll use virtualize. We need to pass items to this component, which in our case will be tasks, and also the context, which in our case will be this item. So here, instead of iterating with for each, we use virtualize and pass items, all elements, and the context, which will be the item from the given element. If we make these changes, you'll notice that we don't need to change anything else inside this component. Okay, and let's also add a spacer element which separates the individual records. In our case, it's tr, the row in our table. If you run the application, nothing changes from the user interface perspective, but let's try to display more data and I'll show you what has changed. So let's move on to the C# code. Here in the onInitialized method, we fetch tasks from the database and initially store them in a variable called tasks. Now, let's multiply them, for example, 100-fold and assign them to our tasks field. So here we have the initialization and now we will add the elements fetched from the database 100 times to the task list. However, for this to work, I need to change the type from iList to list. And now I can use addRange. Okay, so I added a helper variable where I saved all the tasks from the database. Then I initialized the field that is bound to the virtualized component, which is tasks, and added all those tasks from the database 100 times. Now if I run the application, you can see that we have a lot of data on our component. And now, if you go to the developer tools and look at the table, you'll notice first of all that in the T-body, we only have the elements that are currently visible, which is about 20 elements. However, as you can see, the table contains many more elements, I think around 2000. So if you inspect the DOM, you'll see that only the elements currently visible on the screen are being rendered. If you scroll here, the records keep changing and only those currently on the screen are visible. Additionally, you can notice that the height of the currently displayed records is shown in the DOM. For example, if we are at the top, the height is 0, but if we scroll down, the height value changes to reflect our current position. This way, our application knows which records we are currently viewing and only those records are rendered. This kind of virtualization greatly improves the rendering performance of the data. As I mentioned, it's worth using virtualization if you have a lot of data to display. I will now restore the code we had earlier to avoid artificially increasing the table size. I will leave only the records from our database to avoid breaking our application. That's all for this lesson. That's what I wanted to show you about virtualization. As you can see, the implementation is very simple. Instead of a for each loop, we simply use the virtualized component. That's all for this lesson, and now I invite you to the next one.